Okay, now you need to take this to the bank and you need to do it and remember it because your homework for tonight is all about this. Okay? The new homework. It's interpretation. Now, there's also going to be some other stuff. We want to interpret the rise, the run, the width, the slope, the average altitude, the area, and the accumulated area. And you know that every one of those things comes into play when you're doing this, right? And we've seen how it happens, okay, or how we use each one, but we want to know what each one means in terms of our interpretation. So if we're doing the rate of plant growth in grams per day versus days, then this thing has a different interpretation than it would if this was the rate at which our radioactive sample is losing its activity, okay? Or if the graph was just how deep the water is versus time. And in that case, as it turns out, the area doesn't really have an interpretation. Okay? Or at least not a real significant one. Okay, there is an interpretation you could put on it, but it'd be a stretch. So the other thing I'll mention right now, and you want to remember this, is that area doesn't always have a significant interpretation. Everything else does. Okay? In this case, the area obviously has a significant interpretation. And the area has an interpretation if the graph is of a rate. If the graph is not of a rate, then the area probably doesn't have a significant interpretation. I'm just saying that. I'm not going to write it out because we're running a little shorter time and I've got to find a way to get over. Well, we'll take a break and I'll get over and talk to people and see if there's anything we got to know before tomorrow. Okay? Make sense? Mm-hmm. Okay. So tell me, in terms of this interpretation, what's the rise mean?
Which it goes up on the y-axis.
Huh?
How much it goes up on the y-axis or down.
How much it goes up. It is not a good pronoun to use. It's not a, we want a noun.
The rate at which the rate is increasing.
It's not the rate at which the rate is increasing, although that turns out to be what the slope tells you. What's the rise tell you?
Oh,
How much the y
Oh,
value changed.
yeah, if you were thinking of the slope, that was good.
How much the y value changed.
Yeah, no, in terms of this interpretation. It is how much the y value changed. What's the y value?
how much the plant grows.
Yeah, how much it grows per day.
It's the growth rate, right? So the rise is change in growth rate. And I don't like the way I just phrased that because growth rate really has a different meaning in terms of compound interest, and it's not a rate of change. Change in the rate of mass increase, and actually that deserves a few more words. I don't have room or time to write it down, so this will do for right now. We'll clarify it later. Okay, what's the run?
The number of days. Or the amount of time.
Yeah, it's the okay? So maybe I should say change in the rate of mass increase with respect to time. So since this is change in time, right? We probably ought to specify how time is involved with this one. Okay? So let's see, what's the average altitude? In width, well, the width of this thing is the same as the run, isn't it? Okay? Okay, so we'll leave slope off for a minute. Average altitude is what? It's the,
Growth rate.
it's the average rate of change of the mass with respect to time, right? Because the altitudes represent that, okay? And when I say interpret, we really do need to interpret altitudes. You know, that's the first quantity. By the altitude, I mean these things, right? Okay? So the average altitude is just the average of the graph altitudes, which is the average of whatever the graph altitudes represent, which in this case is rate of change of mass with respect to time. Okay? And then what's area? Well, it's the average rate of change times the change in time. To abbreviate it, I'll write it this, right? And in this context, this is, yep, very good. It's the change in mass. Okay? And then accumulated area.
It's the total change in mass since the beginning of the.
Very good. I'll say total mass change from the start, but you really want to think as specifically as you can about what that is, okay? Okay. Well, if you can interpret this for a given situation, and sometimes it gets really complicated to interpret these things. It's real hard to understand what the interpretation is, but in many really important cases, it's really easy. You just got to think through what the units tell you and what the quantities mean. Okay? And it's all very similar to this. Well, in calculus, there are two basic operations. One is differentiation, which is finding a formula for the slopes. Okay? Well, just finding a formula gives you the slopes. I can tell you what the formula is. The formula for the slopes of this thing is 2 to the x times the natural log of 2. You plug in 2 to the x times the natural log of 2 into your calculator. For x equals whatever the midpoint is here, in this case 0.45. Put in 0.45 here, you're going to get something very close to this. Okay? And there are rules for doing this, and the rules get a little complicated. The initial rules are very simple. Okay? And the other operation, I'm not going to teach you calculus here. If you want to learn a little bit of calculus, I've got a good exercise. Just email me. Everybody can do it. I mean, it gives you the rules for the basic functions. It tells you how to do that. Okay? For almost any basic simple function that you might encounter. But when you combine the simple functions, then you get into rules that get a little more confusing. Okay? Anyhow, that's the connection here. Okay? And this is why we're doing this, because people come out of calculus and can't do this. They can't tell you what the slope means, even though they can do derivatives and apply all the rules. They can't tell you what the areas mean, which is the other process, inverse to derivatives. That's integration. Okay? But we understand that the area here is a very significant quantity if you're studying these plants, right? If you're a plant botanist and you have these models, you understand how this could be very profound, right? So this picture bypasses all the rules of calculus. They don't want to bypass them because they tell you things too. Okay? But a lot of what you can do with calculus, you can do with this picture. Okay? With as much accuracy as you want if you make your intervals small enough. Now, you don't necessarily understand how that's going to play out, but hopefully by the middle of next week you will. Okay? So this is extraordinarily important for the meaning of the mathematics that we're looking at. Okay? Make sense? Believe me? Nah, nobody believes me. Okay.